This is the NEET 2017 question in kinetic theory of gases. The question is, gas is a mixture of consists of 2 moles of O2 and 4 moles of argon at temperature T. Neglecting all vibration modes, what is the total internal energy of the system? The first thing that we need to understand is, what is internal energy? These gas molecules inside a system will be always having a random motion. Because of that motion, it could be having a translatory motion, rotatory motion and vibratory motion. All because of all that together they get some energy, and that energy is called as internal energy. So because of the motion they get some kind of a kinetic energy. Because of the position, of course, they will get some kind of energy called potential energy. But for an ideal gas, there is no attraction of one gas molecule with other. Between gas molecules there is no attraction. That means they don't possess any potential energy that equal to 0. So internal energy equal to kinetic energy itself. If you are talking about a monoatomic gas, internal energy is like 3 by 2 RT. But here our problem consists of diatomic gas and monoatomic gas also. So we can write in general, internal energy can be written as F by 2, where F is the degrees of freedom, and nRT, where n is the number of the moles, where F is degrees of freedom. What are the ways that it could move? For example, for a monoatomic gas molecule who is having only one atom, it could move along x-axis translatory, along y-axis, and along z-axis also. So it has translatory motion along 3 axes. So its degrees of freedom is 3. Being a single molecule, it cannot rotate, and it is vibratory modes are ignored in this case. Therefore, it has a degrees of freedom of 3. So this argon, what is given for you, has a degrees of freedom of 3. And the other one is oxygen, right? We can say oxygen. Oxygen is diatomic, O2. For a diatomic, it has a translatory motion like a monoatomic gas 3 times. And one molecule can rotate about the other. So it has a rotatory motion about 2 possible axes. So the total degrees of freedom equal to 5. Taking those two things into consideration and knowing this formula, you can write total internal energy as internal energy of the first one and the internal energy of the second one. Internal energy of the first one is, we can write a formula F1 by 2 N1 RT. For the second one, F2 by 2 N2 RT. F1 being a oxygen has a degrees of freedom of 5. Oxygen has number of the moles are 2 RT. F2 being argon has a degrees of freedom of 3. Number of the moles of the argon are being given for you as 4 and RT. So this becomes 5 RT, 3 and 2 is 6 RT, 5 RT and 6 RT is 11 RT. So the answer for your problem is 11 RT. So the most important thing that you need to know is to solve this problem. The general expression for internal energy of a gas molecule is F by 2 nRT, where F is degrees of freedom. For monoatomic, degrees of freedom is 3. We have explained this in multiple videos. You can go to the playlist and find out why that is like so. And for diatomic, that is equal to 5. For diatomic, it is 5. Knowing these two things, we can simply get to the answer. That's it, and thank you for watching.